Okay, so the next speaker for the day is John Peterson. So he's from Book. Now John is going to make a new type of presentation. This is the first time I'm seeing it. You recording it? So he's going to make a presentation from his iPhone. I usually make presentations from my iPad, but this is the first time you're seeing from my iPhone.
I control it with my iPad.
Oh, he's going to control with the iPad but presenting from an iPhone. Okay, that's wonderful. Okay, let's welcome John and let's say listen and ask more questions about what his company has been doing. So John gave a presentation in GDG 3 years ago, 2009 December. So he has, I think, lots of applications he's developed since, and specifically applications that use the open data. Right? John, take it away.
Thank you very much. Okay. Good afternoon, everybody. This is normally the nightmare slot for the day, right? Because normally we're all really tired, and I'm following a bit of a technical session, so please bear with me. I'm going to be talking for about 45 minutes. If you want to ask questions at any time, just yell and ask questions, but we'll also hopefully have some time at the end for questions as well. My slot is basically going to be talking about sharing experiences building mobile applications using government data. So this morning you had various talks presenting to you agency data from various Singapore government agencies, talking about data.gov.sg, which is the kind of portal to those data sets. What I'm going to be sharing with you is some experiences we've had over the last few years working with that data and building some applications. So let me just quickly go back a slide. There's a couple of contact details here. If you want to email me with any questions, it's john@book.com. My Twitter handle is @Singio. Okay, so if you've got any questions you just want to handle offline, you use those to contact me. So the company that I kind of represent is a company called Book. We're an application developer, specifically mobile applications. We've been around about 4 years, and over the last 4 years we've developed around about 70 mobile applications. They are primarily iOS and Android. Has Justin left the room? Yeah, Justin's left the room. We do a little bit of BlackBerry work, or we used to do a little bit of BlackBerry work. And you never know, we might do some in the future. But at the moment our applications are basically iOS and Android based. Those applications are a whole bunch of different things. We don't do games, we don't do utilities. So what the applications tend to focus on is they're about presenting users with information. That's kind of the core of our development skills, is about taking data, presenting that data to users so they can make some sort of decision or solve some sort of problem. Now that'll make more sense when I start to actually share some of the apps with you. A lot of them clearly are apps that are built for commercial customers, because that's how we kind of run our company. We're a company of 20 people, we have to pay the bills. So we build a lot of applications for commercial organisations. Our biggest customer is probably SPH, publisher of the Straits Times. So we manage the Straits Times apps for them, and we manage Business Times for them, and a few other ones. So we have a whole bunch of commercial customers. But we also spend a lot of time working on our own apps. And for our own apps, typically what we're looking to do is we're looking to experiment in some way. So when we build these apps, we're looking to try and test out some new ideas, possibly to do some internal training for some of our newer developers. They're basically kind of our playground. So much like a lot of independent developers kind of start in their bedrooms, they kind of think, well, what app am I going to build? I need to get some data to build an app. They go off and they look at free sources of data. And the biggest free source of data in the world is the government. Governments around the world collect and store vast amounts of data. So we as a company do basically the same thing. When we're looking for kind of to play around in our sandbox, to test out new ideas, maybe it's a new interface idea we've got, or maybe it's a new, we want to play with web sockets or something, then we go out and we look, well, how can we do this quickly and cheaply? And a typical source of data will be one of the government data sets. So some of the apps we've built, and I'll be demoing a lot of these to you during the session, which is why I'm trying to present from my iPhone. A lot of these apps are free apps that are based around government data sets that are available through data.gov.sg or from other sources. So let's talk a little bit about working in general with government data. I've been working with Singapore government data for about 10 years now. Before I was in mobile development, I was doing a lot of mapping, building maps for people, presenting information in maps. And working with government data 10 years ago was like dealing with waste management. So we had a speaker this morning from the NEA who was talking about waste management. And he didn't quite describe it as shit collection, but it's kind of, you know, this is what working with government data was like 10 years ago in Singapore, and pretty much worldwide. Because working with government data was tough. There were lots of complexities around whether the data was accessible, whether it was accessible legally, if it was accessible, whether it was structured in some way. So dealing with government data was very difficult. Things have improved considerably over the last few years. So this is a bed of roses. So we've moved from kind of waste management to the kind of bed of roses. So dealing with government data today, I wouldn't actually say it is a bed of roses, but it's a lot better than it used to be. The government attitude towards data in Singapore has changed considerably since I've been living in Singapore. If you went to a government agency 5, 6, 7 years ago and asked them for their data, well, they wouldn't even talk to you. Now there are many initiatives across the government agencies to open up the data. So things have got a lot better. So what I'm going to be sharing with you is how we take that data now and build apps from it. Some of the topics that I want to cover are basically these. How we access and store that data, how that data may or may not need to be augmented, and I'm going to be talking in some detail about various crowdsourcing experiments that we've done about trying to augment kind of government data with dynamic data from the crowd, the users of your app. I'll talk very briefly about working with geographic data. Around about, I would say, 80% of the apps that we build with government data have some geographic component to them, because most of these government data sources are about things that have a coordinate to them. They have a position in the world, and you want to represent that in some way. I'll talk a bit about some technical challenges that we faced and how we've overcome them, or failed to overcome them in some cases. And I'll talk to you briefly about what I think are the opportunities in this space for creating interesting stuff, which I think is kind of why you're all here, right? Because you're going to be part of this competition. Hopefully as a result of that, you're going to build some interesting apps. So I'm going to talk about what I find interesting and what I think are some of the opportunities in the space. Before I look at some apps in detail, I just want to talk briefly about data. Okay, the basis for all of the apps that I'm going to show you, the basis of this data.gov.sg is this word data. So does anybody recognise what this is? I tell you are really. Okay, there's some old people here. There are some old people in the audience, right? This was actually the first way I ever interfaced with a computer. The first programs I ever wrote were using a statistical package called SPSS. Okay, I don't know how many of you know SPSS. They're now actually owned by IBM. But back in the days, SPSS been around since 1968. SPSS are one of the oldest software companies in the world. Well, no longer independent, but they've been around a long time. And when you used SPSS when I was at college, we had what was called a Harris mainframe. And the way you interacted with the mainframe was to create these punch cards. And the punch cards had Fortran programs and stuff, and told the computer to go off and do things. And you submitted them, and you came back the next morning, and if you'd got a comma in the wrong place, the whole thing would crash, and you had to recreate the punch cards, submit them to the queue, and so on. But basically what this is it's data, right? So this is how we used to interface with data. We used to get data, we used to code it onto a punch card, and we would feed it to the computer. Now, we've moved on considerably, right? These data sets are now stored, hopefully in structured relational databases, in the cloud, instantly accessible via APIs in real time, and so on. So things have moved on a long way. Let's talk briefly about forms of government data, because this morning you were presented with various sources of government data, and often this data is called open data, and often the form open data is mixed up with the form open government. Okay? Open government and open data are, of course, two completely different things. You can have open data and not be an open government. You can be an open government and not have open data. But the second one's a little bit harder to do. Right? Because by being an open government, you're probably going to have open data. But you can certainly have open data without being an open government. And there are different forms of government data. Okay? As I mentioned earlier, the governments around the world are probably the biggest creator of data. They have a lot of administrative data. Okay? Data about government. Data that defines a parcel of land. Data that defines who that parcel of land belongs to, and so on. And they have a lot of statistical data. So typically the biggest statistical source of data for any government is the census. Most governments around the world run a census, typically every 10 years. That statistical data from the census becomes a body of data that they can use to mine and create decisions from. But actually what we're really focused on in our apps is the operational data. Okay? It's the data that the government is collecting about how things are operating on a day-to-day basis. How is the bus network doing? How many people are on a bus? How many people are waiting for a bus? How many car accidents have there been in the last 30 minutes? Where are those accidents? How are they affecting traffic? This is all operational data. And this operational data is becoming richer and richer because the abilities of government to collect real-time data have grown exponentially over the last few years. We had a conversation earlier about the gantries on the ERP gantries. Those ERP gantries are collecting real-time information on which cars are travelling, or where they're travelling, or what speeds they're going, and so on and so on and so on. So there's this vast, exponentially growing body of operational data. And typically that's what we're focused on when we look for opportunities for apps. The reason we do that is that the sweet spot for us, for mobile apps, is about real time. The mobile device is attached to me 24 hours a day. It's a real-time device in a way that we've never had a real-time device in the past. When I was confined to my desktop because my computer wasn't portable and I didn't have a 3G connection, real-time kind of made some sense while I was at my desk, but otherwise it was useless because I had no device that I could communicate with in real time. Now we have a device that allows me to receive stuff in real time and, just as importantly, send stuff in real time. So I can receive stuff, such as when is the next bus coming, and I can send stuff, such as where am I now? Okay? So we've got this two-way connection mechanism for data, and we've got this operational data that we can work with. The other thing about this real-time data is that it's not just data that we give proactively. We're also carrying around, it's not in my pocket, it's on my desk, but on the desk here, this iPhone, and whatever smartphone you have with you has been doing basically the same thing. It's basically a little bag of sensors. Okay? It senses, the one thing we're all most familiar with, of course, is our location. It senses our location. But it also has within it, for example, a compass, a barometer, an accelerometer. So it's a bag of sensors that are collecting real-time data about our environment and potentially sending it somewhere where it can be made use of. So we have this fantastic combination, this kind of sweet spot in the mobile world, where we have this growing pool of real-time operational data combined with real-time data from this sensor that we're carrying around with us, that knows where we are, when we're there. It knows the weather, it knows our altitude, it knows all sorts of things. In the future, it will know the air quality. Okay, someone was talking about PSI and air quality this morning. It won't be long before the phone is able to tell me that I'm in an area where I need to take my hay fever meds, right? Because I have allergies to certain things. My phone will one day be able to detect if I'm close to those things and tell me you probably need to take your medication now because you're in an area where you're going to start sneezing. Right? It's a bag of sensors collecting and sending data in real time. And this opens up huge opportunities for doing some kind of cool stuff. So, on that note, let's start looking at, go back to the data again. And I want to just pose some questions about data. And kind of the first one, I guess, if you're thinking, well, what app am I going to build? You're all probably going to have to come up with some idea or take one of the ideas that's already been submitted about what app to build. The kind of question we always ask ourselves is we need to try and make this very user-centric, this conversation about what app we're going to build. So who is the user and what problem is the user trying to solve? Now, one of the most well-known apps in Singapore that is on most people's phones is an app called SG Buses, or you may have SG Next Bus, which is its kind of partner application. How many people have got SG Next Bus or SG Buses on their phone? Okay, surprisingly few. That app, believe it or not, has had over 1 million downloads in Singapore. Okay, I'll talk a bit more about it in a moment for those of you who haven't heard it, but basically it's an app that tells you when your next bus is coming. That's a very simple concept. So who is the user? Well, the user is a bus user. It's someone who takes the bus. What is the problem they're trying to solve? They're trying to figure out how to not waste time at a bus stop. Right? We don't want to waste time at a bus stop. We could be sitting in a cafe or we could be sitting at home. Or they're trying to figure out which bus to get. Because the bus, they may have different options amongst the various buses that they could take to go down a particular route. And they want to choose which is the best bus to take. And when is it going to arrive? So it's a fairly simple problem, and it's fairly easy to describe the user. So having posed the problem, the next question is, well, what data do you need to solve that problem? So what data do we need to solve the problem if somebody needs to know what time the next bus is? Well, we need to know what bus they're interested in, right? Because there are I believe about 460 different bus services in Singapore. There are about 5,200 bus stops. So they could be they're likely to be interested in a small range of those 460 services, probably at a very specific bus stop or maybe 2 bus stops. So we need data that supports just giving them that bit of information. And that, of course, is their location. So if we get their location, we know what bus stops they're near. If we know what bus stops they're near, what do we need to know what bus stops they're near? We need a database of all bus stops. So we can take the user location, match it to the database of all our bus stops. Now we need to know which services run through those bus stops. So we need a database of all the bus services and match them to every bus stop. And suddenly we've got a data set, the user location, the bus stop location, the services that run through the bus stop. We now have all the data we need to solve the problem. Okay? So this is pretty simple stuff. Right? It's framing the problem, deciding which user has the problem, deciding what parts of the data you then need that either come from the user or that come from the operational data, which in this case is the bus system, the transport system. You match the two and you solve the problem for the user. You get 1 million downloads, you put adverts in your app, you start making a bit of money. Okay? Let's move on to something else. While I'm going to come back to data and talk a bit more specifically about some of these issues around solving that data problem. But one of the other things I want to kind of frame at this point in the conversation is when I'm showing you these apps and I'm talking about the way we try and solve problems with these apps, we're very focused around trying to do it right for the environment the user is in. And the environment the user is in with mobile is a very, very interesting one because it has a lot of variability to it. They could be in various different locations, so the user could be moving around. They could be walking. They could be in a car. They could be in a bus. They could be on an MRT. They could have a good network connection. They could have a bad network connection. They could have no network connection. Okay? So one of the conversations we always go through with our clients is there seems to be this desperate need. It's kind of disappearing a bit now. In the early days of mobile, and still with a lot of our large customers, there seems to be this desperate need to try and replicate on mobile what we did on desktop. And almost without exception, it's a disaster. And this kind of touches on opportunities, because I'm going to talk about opportunities later. Because if you look at the way the government organisations in Singapore generally present their own data, what most of them have done is they've tried to replicate the desktop on a mobile device. If you look at, I don't want to name and shame, but actually you could almost look at any Singapore government ministry mobile site, and they are like a replication of the desktop. If you look at the NEA site, it has everything in it. The NEA site has everything the NEA does. It doesn't matter whether it's monitoring the cleanliness of hawker stalls, or it's fighting dengue, or it's monitoring PSI, or it's managing waste. They take the whole lot, stick it in an app, just like they stick everything in their website. If you look at the NLB, National Library Boards, it's exactly the same thing. They take everything they did on the desktop and they try and make a mobile site. And these mobile sites are useless. Well, no, they're not useless, that's unfair. But they're close to useless. They don't work on a mobile device. They don't work because my environment is different. The quality of my connection is completely different, just the way I use it. How many of us are using our smartphones as we walk, right? That's the environment we're in. So the way I like to think about this is, an awful lot of sites out there, particularly ones focused on government data, are built like desktop web sites. They're container ships. They're container ships where every single department of that government department has a little container where they're allowed to put whatever they want, right? And you end up with this container ship, and nobody uses it because it sucks. What we're focused on in mobile, what we're really focused on is we want to build speedboats. Okay? Speedboats, not container ships. Mobile requires building for speed. And when I say building for speed, that's at a number of different levels. Mobile needs to be built for speed of connection. We're still in an environment where we could be on crappy connections. Okay? Even in Singapore, at my home, I do not have a 3G connection. I get a GPRS connection. I may be lucky enough to get LTE, in which case I'm in heaven. My LTE connection, believe it or not, is faster than my fibre connection at home. But on my mobile phone, I don't know when I'm going to be on GPRS and when I'm going to be on LTE. And when I'm on GPRS, my container ship is definitely not going to work. It won't even dock in the harbour, right? Because it's just too big and fat. So we're talking about speed in terms of just speed of dealing with these very thin pipes that we may have to be using to transmit data. But also there's the whole speed element of the things I want to do on a mobile phone, I need to do fast. If in 20 seconds I can't get the time of my next bus, I'm not going to use that app again. If in 20 seconds I can't find out which library to go to borrow the next bestseller book, I'm not going to use the app. Apps are very often focused around these very short, quick tasks that we need to accomplish. And we're all, even in the world of the web, right, we've all been losing these, our attention span's been kind of going like this. I don't know what the current research is about how fast a website has to load before you get off it, but it's something like 6 seconds or something, maybe less than that, right? But basically, we need to deliver up and solve the problem in the mobile world really fast, even faster than we do on traditional web. And we need to do it down what could be a really slow pipe. So we need to be faster because people are in an environment where they're less patient and they have less time because they may be walking or the environment's changing. And we need to be fast in network conditions that don't lend themselves to it until we all have ubiquitous kind of LTE, right? Okay. So let's look at some of these apps in a bit more detail and talk a bit more about the data. The app I've already talked about is an app called, this is SG Next Bus. SG Next Bus, a very simple app. If you open it, this is all it does. It's kind of a one-page app. And one-page apps are often the best, right? If you need 2 pages to your app, what are you doing? You're trying to solve nuclear, solve world hunger or something. Most problems can be probably solved in 1 page. Not all, that's a bit of a simplification, but if you can do it in 1 page, that's wonderful. In this case, why not do it in 1 page, right? It's just a list. This is a screenshot from here, actually. So I use the app here, and it tells me my nearest bus stops, which buses go there, and I can look at when they're going to arrive. Okay, so those apps require data. I've talked about what data was required for that app already. Some questions about the data. Is the data available? Typically the answer is yes, it's out there somewhere. But available doesn't mean you can use it. So there are issues of, is it available technically? So, can you build something that is going to be able to collect this data in real time and deliver it up to 150,000 users a day, which is what SG Buses does, right? Sorry, SG Next Bus. SG Next Bus, 150,000 people a day use the app to find out a bus time. So you can't kind of be running around behind the scenes, figuring out what the bus times are. It's got to be something that's repeatable extremely fast via some API. So is the data available in a technical way that will allow you to serve up all of those requests? Is it legally available? Now, a lot of these legal issues are getting easier to handle because of the data.gov.sg initiative, which is handling a lot of the legality issues for us as developers. So they've talked to all of the agencies have kind of bought into the various terms of use that you need to sign up to when you download those data sets. You don't have to go and negotiate with each one separately and so on. But you will still find, unfortunately, that there is data that you want to use where the legal use is questionable. In the past, when I was doing this 7, 8, 9 years ago, I was stealing all the data. Right? And we still occasionally steal data. And my attitude to government data is kind of the taxpayers already paid for it, therefore I own it anyway. Now I know legally that would not hold up in a court of law. If I got a lawyer's letter, I would have to stop using it because I'm not going to be sued. But my attitude is, if it's been paid for by the taxpayer and it's out there on the web, go scrape if you need to scrape. And if the terms of use of the site say you can't scrape us, ignore it. Okay? Don't quote me on that, but basically we've been doing it for years, nobody's ever come after us, and whenever we talk to the government people, they all kind of say, yeah, we don't care. Right? Those terms of use are in there because some lawyer somewhere is covering their arse. Okay? So these legal issues, they are still there, and you need to be careful with them. In Singapore, around the government, I wouldn't care that much because I think the government's attitude in Singapore is good towards this now. It's pro the developer community, it's pro opening up the data. But you do need to be careful as soon as you touch data from a commercial organisation. Okay? And you know who I'm talking about in the transport world, right? Yeah, those two animals in the transport world could be a bit touchy, and they've got expensive lawyers. Okay. So let's go, I talked about, is it available technically, is it in a form that it supports the technical functions of the application? Well, you're all familiar with these terms, of course, right? Data is going to come to you in lots of different forms. Even if you go to data.gov.sg, if you look at the links there's a whole bunch of stuff. Some of it is shape files, some of it is JSON, some of it is XML, some of it's CSV, and unfortunately an awful lot of it is a big URL, a link to a web page. Which is that's not a lot of use, right? But generally, this is the kind of path that you're kind of working down. You hope to God it's not in an Excel file, because Excel file, people always put in stuff that destructures data in Excel files. They always put in like headings and titles in the wrong place and so on. If it's in HTML, you may just be able to scrape it. If it's in CSV, wonderful, I love CSV files, very easy way to consume data, very fast to consume. All you really need to know is have some metadata that tells you what's in each column, and typically in a CSV file, that's the top row, right? If it's not there, you can normally guess. XML, we kind of love XML because it has these nice tags around the data that forces a structure on it, and the tags may even describe for us what the data is within the tags. Unfortunately, in the mobile world, XML is a bit fat. The XML language is just very verbose. You do not need a beginning and an end tag, right? One of them is redundant. So we generally far prefer to work with JSON. Okay, JSON data is much more compact, but has the same descriptive strength of XML. Okay, so you have to kind of look at what format the data is in. Based on the format, you're going to have to parse it. Yeah, assuming you may parse it in the app. So your app may call the provider's API, take their data, parse it, whatever it is it sends you. It may send you XML, you have an XML parser. It sends you JSON, you have a JSON parser. Then your parsing feeds the interface, populates the interface. In virtually all of our apps, we will have some caching layer in between. So typically, we will have a server which calls the web service of the provider, grabs the data, parses it server-side, feeds it to the app in JSON. Okay? We don't really want our app developers building parsers. Because people who are really shit hot in Objective-C and build wonderful, beautiful interfaces, you do not want them spending their time on parsers. Parsers is grunt work, it's for people like me. Yeah, I don't do the user interface stuff, I can't do it, I'm not competent at that. But I can build a parser. If I build the parser, then I leave the sexy stuff to the guys who are really good at that. So we try and shift all that grunt work out of the app if we can. By keeping it out of the app, you also retain a lot of flexibility to change the way it's done. One of the things that Apple has locked us into is this whole reviewing of apps, right? So if something breaks in your app and you're parsing client side, okay, and typically it will break because the source of the data has changed it, right? So your source of data, let's say for example it's bus timings, your source of bus timings data has changed. Someone's gone and changed an XML tag. It gets to the app is broken. You fix the app, you submit it to Apple, 10 days later you've got a new app and you've lost all your users. Okay? So the more we can shift that work to the server side, the more we can fix these things on the fly. So we build all our parsers server side, we have huge monitoring tasks that make sure those parsers keep running and send us alerts when they break. And they will break because the data source will change. Shit happens, right? But we can react quickly, we can get the app back up and running very fast. So is the data rich and timely? Someone asked earlier about how do we, I think one of the questions this morning was how do we know when you've updated your API, somebody asked. Well, how do you know when you've updated your data behind the API? Typically you don't. They don't tell you most of the time. So for example, if you want to take the bus data out of data.gov.sg, which is XML on all of the bus routes, they never tell you when they've added a new bus route. Okay? Fortunately, we have kind of enough computing power at our hands nowadays, and bandwidth is so cheap, that actually there's nothing much to just stop us checking at a regular interval. So we just go off and we grab the whole data set, we bring it in and we see if anything has changed, because typically they won't tell us if it's changed. So is it rich? No, by rich I mean does it have the information you need? Is it timely? Is it going to stay up to date? Because if it doesn't stay up to date, you're not going to be providing the right information to the user, you're not going to be solving the user's problem, and the user's going to stop using your app. Is it geospatially referenced? Like I said earlier, about 80% probably of our government-based applications, we use geospatially referenced data. In the case of the data, if you decide to get your data out of one map, you will have a coordinate issue around that because of their use of SVG 21. Okay, they use a different coordinate system. But actually to switch the coordinate system is not difficult, and you can either use their API to do it, or you can find some library that will do it for you. We use a library called Proj, P-R-O-J, which allows us to switch coordinate systems on the fly. So if we get geographic coordinates in the wrong coordinate system, it's very, very simple to swap them around. If it's geospatially referenced, how well is it geospatially referenced? Does it support, there's a few wrinklies, for example, depending on what type of service you're using. If you, for example, have some data you want to reverse geocode, so with reverse geocoding, we take a lat long and we turn it into a human readable address, right? So I take my lat long at home, it tells me it's 32 Chapel Road, Singapore. With Google's reverse geocoder, if your point is in the sea, it will fail. Okay, it won't tell you that it's in the sea off Singapore, okay, it just falls down. And there are bits of sea all over the place, right? So we had an interesting problem where we had this issue with one of our apps where we were getting problems with users in Vivo City. Okay, so people were inside Vivo City. The app was telling us their location was actually in the sea, just outside Vivo City, kind of between Vivo City and Sentosa, because indoor location is not very accurate, right? It can have some, level of inaccuracy to it. And in that case, it was telling us that they were in the sea. It was only like 100 meters from where they really were. It was, that location would have been good enough to say, yeah, we kind of know where they are. But as soon as you reverse geocode it, Google says, that place doesn't exist, right? So there's all sorts of issues with data around its geospatial nature, how that geospatial data is stored, what coordinate system it's in, and also how you translate that, if you do need to translate it, between a coordinate system and a human readable address. Now, the coordinate system to human readable address is actually a very, very interesting problem in the mobile world. Okay? This is this thing called reverse geocoding. In the mobile world, we do a hell of a lot of reverse geocoding. Much more than we ever used to do. Because what we're often working with in our apps is the user's location. And the device gives us that location in the form of lat long. So we get a lat long from the device and we need to turn it into something that's human readable. Their address or their postcode or whatever it is. But the device is often telling us an inaccurate version of where they are. Okay? Everybody understand why this is inaccurate, right? It's because typically you're inside a building, the device is now using assisted GPS, it can't get aligned to satellites, so it's using Wi-Fi or it's using a worse cellular tower. Now all of a sudden, I'm in this building, but my device will tell you I'm in the middle of the expressway. Right? Because that's actually not very far away, and it can't pinpoint me right here because I can't get satellite line of sight, but I'm inside the building. So we get this lat long, we try and figure out that I'm in whatever this address is, 71 Raja Crescent, and I'm not in this building. And we're doing an awful lot of that in our apps, because a lot of our apps rely on us getting the lat long of the user and then doing something sensible with it. Another gotcha, if you like, on geodata, I talked about Google not doing reverse geocoding in the sea. The OneMap reverse geocoder will not work if you are not inside a building or within, I think it's 20 meters of a road. Okay? So if I send my lat long to OneMap's reverse geocoder and my lat long is within the perimeter of this building, it's fine. If it sends my lat long and it's out in that car park, and that car park is more than 20 meters from the road, it will say not found. Okay? So if you use OneMap's reverse geocoder, you get a lot of not founds. You could be driving along the ECP, but actually the device thinks you're in East Coast Park, and OneMap will say not found, because you're not within the perimeter of a building and you're not within 20 meters of the road. Okay? So working with geodata is kind of a bit messy because of these issues around what is the person's true location and how do we use that location if we need to turn it into something that's human readable, which is what we're normally doing with reverse geocoding. And then there's the question of kind of real time. Of course, nothing is ever real time because nothing moves at an infinite speed, but everything is either close to real time or further away from real time. If your app relies on real time data, then is the data source provided as a real time data source, and can you get it to your app and make it real time? So if you take the bus application, it's an obvious one where we need close to real time data. Right? If I tell you the bus is coming in 4 minutes, and really I mean 1 minute, you're screwed. I've just failed to solve your problem. Right? You've just missed your bus. I've just made your life probably worse than you just randomly turning up at the bus stop. Okay? So, is it real time? Do you need real time to solve the user's problem? If you do need real time, can you get it and can you deliver it as real time? Okay. Then there's the question of what other data might you need to collect to solve the user's problem? So we've talked about this huge pool of government data we can draw from to solve problems. What do we need from the user? Well, some may be what I call user data, and I've talked about that extensively already. Typically it's something like their location. So it's data the device can give us about the user. So this is user data that the app can gather as it solves the problem. And then there's user input. Do we actually need to get the user to give us something? Okay? And the next app I show you will make more sense in terms of that user input. Getting stuff where the user has to proactively give us some information. Okay, demo time. I'm going to try and demo an app to you quickly, which is an app called NextRide. And NextRide is it's an app to allow you to plan routes on the Singapore public transit network. Okay, the public transit network in Singapore, for those of you who aren't familiar with Singapore, I think most of you are, basically it's buses, MRT, LRT, a few ferries, bumboats if you want to go to Pulau Ubin, the Skyway if you want to go to Sentosa. There's a private bus system on Sentosa. So there's various parts of the transit network that you can use to get around. And this is an app, a bit like Google Maps, to help you find out the best route. So let's just do a quick demo and then I'll talk through some slides in a bit more detail. So I'm just going to plan a route. So that was the route I used to actually get here, so I'm just going to reverse it. So I'm going to go from my current location to 32 Chapel Road. Now that 32 Chapel Road is something I've input. So this is an example where we're getting user data from me that I have to input myself. My current location I don't have to input myself, right? The device knows that. So current location is just found by the device. But I need to put my destination. So if I type in 32, it's going to come up because I've already typed it in. But you can see it doing the search here. So it's doing an auto-suggest on the fly, which is using an API to call a web service, which is going to try and figure out the address as I type it. So if I get to 32 Chapel Road, I just need to type in those characters and it's top of the list, right? So we're getting my user input, we're using my user input to call a web service, using that web service to help me solve this problem quickly. I need to be able to find my route in less than 20 seconds. That was my kind of task, my kind of threshold I mentioned earlier. Solve the user's problem in 20 seconds. So one way we can do that here is to use auto-suggest on their input. This is actually using the OneMap basic search API. So if you're getting user input on addresses in your application, use their API. It's the basic search API, and it's great. Their data is extremely rich, and that particular API is very fast. A lot of their APIs aren't fast, but that one is. It's fast enough to use as an auto-suggest service. Okay? So I say I want to go to 32 Chapel Road. I hit 32 Chapel Road and I get my bus route. And it then tells me my bus is going to be here in 7 minutes. So it's told me it's going to take me 66 minutes to get home. It's told me I need to walk 431 meters to this bus stop that's 3 minutes walk away. I'm going to get on bus 197, and I get a push message saying the next bus 197 is going to be arriving in 7 minutes. So I can't go home in 7 minutes. Well, I could actually. Or in 13 minutes. Okay? So there, I've just solved my problem. Right? In hopefully 20 seconds, I've put in a little bit of input. I have to type maybe 6 characters. And I've got a route home, and I know when I can get that route home. And we've got some kind of alternatives here. So there's another route which is going to take 66 minutes, which is actually a combination of MRT and bus. So my fastest route home is bus, but I can do bus and MRT as well.
What about the cost?
We don't have any cost in here. All we're doing is we're showing you the route. There is an API for cost. The data set we pull has costs. We just haven't quite figured out how to build it in yet. Okay, so there's my route, and if I want to see it in a map, we've kind of got this rather nice paper fold effect. So I can now see what route that's going to be. You'll see there's the, it was the circle line, right?
Yeah,
that's the circle line, and then there's my bus route. So I'm going to be changing opposite, I'm going to get to Dakota, I'm going to change it opposite Northlight School, and there's my map for showing me the way home. And we've got something rather neat in here as well, which I'm just going to show briefly, and I'll explain a bit more how this works in a moment. But this is the very end of my route. Okay, so this is the bus. After I get off the MRT at Northlight School, I get on this bus, I can't remember which number it is. I get off at this bus stop, and this is my home. Okay? And this is a park. Okay, so the app is clever enough to know that I can walk through a park. Okay? Typically what these apps do is they will send you somewhere around here or around there, right? Because most data sets don't know that this park is walkable. And I'll talk about how we do that in a moment. Okay? And this is something I could talk for the rest of the day about, because it's about mapping systems, which one to use, when to use them. This is actually using something called OpenStreetMap. Okay? An OpenStreetMap has a lot of downsides to it, but it has this wonderful upside. In OpenStreetMap, things can be tagged with an enormous array of properties by the crowd. And in this particular case, this park has been tagged as being a pedestrian area. And if the park is tagged as a pedestrian area, then the routing algorithm knows it can walk through it. I've discovered so much about Singapore through this app, but also so much about the difficulties of routing. This is quite a tricky problem. The hardest part of routing is not the bus and the MRT, it's the walk at each end. And the walk at each end in Singapore is actually very important, because it can either be extremely hot or extremely wet. Often both. Right? So in other cultures, people will tolerate a walk outdoors. In fact, they may even welcome it. 800-metre walk to the bus stop in England, it's nice. Well, England's a bad choice. But an 800-metre walk is not going to be a problem. I'm not going to get there completely soaked, either because it's raining or I've just sweated my guts out, right? So this whole walking bit is very interesting optimization, a very interesting optimization problem, and can lead to some much higher quality routing results, just if you get that walking bit right. The other interesting thing about Singapore is how much of it is walkable. Okay? Because HDB blocks have void decks. Okay? Every void deck is basically an open pedestrian area. So in Singapore, you can walk through buildings. And in OpenStreetMap, you can tag a building as being a pedestrian area. So you can go to a big building, and this is particularly helpful with the big malls, right? You can go to a mall and you can tag that whole mall as being pedestrian area, and suddenly you can walk through it. There'll be a walking route through it. Okay? Okay, let's go back to the slides. So let's talk a little bit about the data. I'll go through this quick because I'm running out of time. There's a lot of other stuff I want to cover, but I just want to quickly recap on the data that is driving this particular app. We have the start location provided by the user without the user doing anything, yeah, because we know they're that long, unless they've turned off location services. Okay, around about 10% of our users will turn off location services. I don't know why. Some sort of weird privacy issue. I bet they've all got Facebook accounts. So why they care about their privacy, I don't know. And we can't use this to identify them anyway. All we can use is to identify the device. But anyway, about 10% of users will turn that off. So you have to get them to input their current location as well. Then we've got their active input of their end location. Then we've got the bus and train data itself. And there is actually a fantastic worldwide format of transit data, which is called GTFS. GTFS stands for Google Transit Feed Specification. And it's a specification for public transit data that Google created in order to be able to get transit agencies to give them data for Google Maps. So if you remember when Google Maps first came out, there was no public transit information in there. So they needed to figure out, how do we give users public transit instructions? And being very bright people at Google, they kind of figured out that needed to be one universal format. And Google kind of had the resources to be able to push that format, and it's been accepted as being the standard open format for transit data. Google don't own it. It's completely open, non-proprietary format for how to structure transit data in a way that that data can be used by applications. Singapore, believe it or not, has GTFS data. Well, no, I don't know this. Okay, so in Singapore, the transit instructions are available in Google Maps, which means that somewhere there's a GTFS feed for Singapore. But if you talk to the people at the LTA, they claim complete ignorance. They say it does not exist. And actually, I think they may be right. I didn't believe them at first, but I think they may be right, because I think what is happening is LTA are actually providing Google with the raw data, and people at Google are creating the GTFS, which is a pain in the arse, right? Because that immediately makes the data closed. This is a transit specification specifically designed to be open to anybody and any application to use. It's completely documented, it's easy to understand, but because of this mechanism of it being passed to a proprietary body, which is Google, suddenly the data is no longer open. I cannot go to Google and request the GTFS data. They'll tell me to get stuffed. Right? Those open data formats need to be in government hands, because the government are the one that can then make it open and truly open. All that's happened in this case is the data's been created, put into an open format by somebody who then is in a position to keep it closed. And I'm not blaming Google for that. Google have done a fantastic job of pushing this, and they've done a fantastic job of providing public transit information around the world. God knows how much that's worth to the global economy. But it's a huge contribution, which is basically free. So I'm not knocking them for this, but just the mechanism by the way it's worked in Singapore hasn't worked out well. So what we've had to do is we've actually recreated the GTFS. We pull all of the XML data from the transport information that LTA have in data.gov.sg. We then run a huge parser which creates the GTFS. Okay? Why did we want to work with GTFS? There's lots of other options, right? We could use routing algorithms from other people. Why did we want to use GTFS? The reason we wanted to use it, and this is something I would want you all to bear in mind when you're building your apps, is we wanted some possibility that this app could work outside of Singapore. If we'd chosen to use, for example, OneMap's routing algorithm for this app, we'd have had to go off around the world and look at different routing algorithms everywhere. What we've chosen is we've chosen one tool which is called Open Trip Planner. Open Trip Planner consumes GTFS, and we can get GTFS for around about 250 cities in the world. So it was a real pain doing it, but what we've ended up with is an app that will actually work in 200 cities. At the moment we've only launched it in Singapore, but you can actually open this app, and there's a little secret trick, which is that you can do a route by pressing 2 fingers simultaneously on the map. So if you pan to Perth, Australia, well, I'm going to try it. This is just too good not to show you. I'm going to use up more time here.
No, it's okay. Very interesting.
Okay, at the moment I'm in Singapore, right? This is kind of where the map is. But I can zoom out. And like I say, at the moment we've only launched the app in Singapore, but I have GTFS data in here now for about 50 cities, I think, including Perth, Australia. So if I go to Perth, Australia, one of the things we've built in as a way to test the app is the ability to get a route by putting 2 fingers on the screen simultaneously. Okay, actually the one that touches first will be the beginning of the route, and the one that touches last will be the end of the route. Now it's a cool demo feature, but it's absolutely useless to the user. Because no user can figure out their route by putting 2 fingers on a map, because you can never be precise enough. But it gives us a way to test lots of routes very quickly. Because you can just go to the app and you can go do, and you can see if the API can feed all the routes to you. So anyway, so here I am in Perth. Let's try it, see if we can get one. Hey, there we are. So this is, I don't know how many of you know Perth. I luckily got a route from somewhere I know, Fremantle, which is a fairly significant kind of landmark near Perth by the sea. So this particular route is it's a long walk, 1.2 kilometres, to a train, which is the Fremantle line, then a 380 metre walk, and then a bus route. And let's have a look at it on the map. Okay, and there's my route in Perth. So I said bear this in mind when you're building your own applications. I know this is very difficult when you're working with government data, because government data is kind of naturally confined to Singapore. But if you want this app to have a wider use base than Singapore, and we all want that, right, because Singapore's so small, think of ways, if it is possible that it could be extended to other countries, think of ways to architect it to make that easy for yourself. Okay? It won't be possible in many, many apps, but in this one it was possible to do that. Okay, I just want to show one other quick thing that we built in here while I'm demoing it. Can you all see that little red circle at the top of the screen? It's either got a dot in it or it doesn't have a dot in it. So I tap it now, I get a little dot. That turns on proximity monitoring. So if I get a route and I tap the little red button at the top, I'll get a warning when I need to change. Okay, everybody get that? It's called proximity monitoring. Basically, we know the location of the change. The change is at Perth Station. We monitor your location using something called background location from the device. When you've entered a proximity of that station, we send you a push message saying, you need to change trains now. In fact, it's changing to a bus. It will say you need to change to bus 388. And if you're in Singapore, it'll even tell you when bus 388 is coming. So it'll warn you when to get off, and then it'll tell you when that bus is departing. Okay? Okay, let's go back to the slides. Okay, so this is here, proximity monitoring. We're doing a lot of proximity monitoring at the moment, and it's fun, but it's difficult. It's fun because this whole concept of, people have been promising for years this idea that you walk past a Starbucks and offers you a free coffee, right? That's been the kind of, the dream of marketers for years, is this ability to, on your phone, give you something that's in close proximity to you to make you a customer. So proximity monitoring is kind of neat stuff and fun stuff to do because of the potential use cases. But it's a pain in the butt because of some of the issues I mentioned earlier. One is lack of accuracy about the user's location. The other one with proximity monitoring, on the iOS platform, the way Apple have implemented it, they've implemented it in a way that tries to conserve battery life. So you only get certain windows of opportunity to get someone's location in the background. What I mean by in background is they're not running your app. Right? The device is in their pocket or they're running another app. They're not running your app, but your app needs to get their location. That's called background location. Apple only allows us to get that background location at certain opportunities. Now, in Singapore, bus stops are about 400 meters apart, and buses can travel quite rapidly between bus stops. So our ability to tell you to get off at exactly the right spot in Singapore is, shall I say, it's something we're still testing. Because we don't want to get it wrong. You know what I said earlier about solving the problem and making someone's life even harder? If you tell someone the wrong bus time, it's worse than not telling them anything. If you tell them to get off at the wrong bus stop, it's worse than not telling them at all. It's a real bad thing to do. Guaranteed way to lose users. Okay, something else this isn't in the production version, but something else that we're building into the next version is, in this particular case, this bus 33 is going to be travelling along a route where there's currently a traffic problem. Okay? LTA provide us with real-time feeds on traffic incidents on Singapore roads. If you get to work with the LTA around their APIs, they're great. Their APIs are very mature, and they do push APIs. We don't have to pull. They'll actually push to us the traffic incidents as they happen. Okay? So we're getting a constant feed to our server of all the traffic incidents. We can work out whether that traffic incident is on bus route 33, or the particular part of route 33 that you're taking. And if there's an incident on the route, we'll tell you. So we can tell you that bus 33, there's a potential for delay because there's been an accident, or there's congestion on that route. So this is kind of it's a really simple app. It's almost a one-page app. It's 2 pages if you count the map. And my ability to solve my major problem is like done in 20 seconds. It gets my current location, I tell it where I'm going, it gives me a route. But if you take all this operational government data that's out there, there's so many other neat things you can do. Things the user may not even notice. Like telling them when that bus is going to arrive. Telling them when they need to change. Telling them if their route is affected by some incident. All this government data is out there, it's just a case of getting it and putting it all together in a way that kind of cohesively solves a problem. And what we're trying to do here, in a way, is not be a container ship, but we are trying to build a rich app. Because the only way we can compete with people like Google and people like GoThere, who they both do a fantastic job, the only way we can compete with them is to be equal and better. With every app we do, we say, can we be equal to what else is out there? If we can be equal and that's all we can do, we don't bother. Okay? But if we can be better, we'll give it a go, particularly if we can learn some interesting stuff along the way. And I tell you, the stuff we learned by building this was just exceptional. That's building our knowledge base, which is kind of what we then go and sell to clients, which is how we kind of pay the wages. This pays us nothing, right? This is a completely free app. Okay, we've covered that already, bus arrival times. I'll talk quickly about an app called Weatherlar. Weatherlar kind of follows a similar concept. It appears first of all as a one-page app, and it's an app which tells you the weather. Okay, so this is data coming from the NEA, who spoke this morning. NEA have a bunch of data that tells you stuff about the environment. In our case, it's the weather environment. So we have a forecast for the next 12 hours. We have a 3-day forecast, what it's going to be like on Saturday, Sunday, and Monday. Everybody says the weather in Singapore never changes, kind of confirms that. In fact, I believe the weather in Singapore does change a lot, it's just that it's a binary change. Yeah, it's like dry, wet, wet, dry, dry, wet, dry. And actually that's quite an important change, okay? And it's the only thing you're really bothered about in Singapore. Is it going to be wet or is it going to be dry? And the reason you're bothered about it is because you have to go outdoors. So the problem we're trying to solve here is we're trying to solve a problem for people who want to go outdoors. Can I go outdoors tonight and ride my bike? Probably not. Right? Rain in the late afternoon is kind of the 12-hour forecast. So there's some indication there that I should be going outside and riding my bike. Something else that may help me make that decision or solve that problem of whether I should ride my bike is whether the PSI is high. So because we believe PSI is an important tool for people who go outside, we put that on the front screen. So if the PSI is over 50 and you've got some respiratory problems, you may be affected. If it goes over 100, you're almost certainly going to be affected. If it goes over 150, you want to stay indoors. If it goes over 200, we're all dead. Right? So the PSI is there as something that kind of reinforces this information about should I be going outdoors at the moment. Okay, so we've got the weather forecast, we've got the PSI. The weather forecast comes to us in really nice XML. The PSI, believe it or not, is still scraped from their webpage. There is no API for PSI. And you probably saw in the presentation this morning, the lady from the NEA, I don't think she's still here, she showed the webpage for the PSI. Yeah, I'm afraid that is their API. Okay, then we kind of, a bit like the routing app, we've kind of then tried to look for ways to make this a bit richer, because there's so many other ways I can get weather data, right? So how can we make this app better than other weather apps? And the way we've tried to do that is a couple of things. Firstly, there's something called a crowdcast. We ask the crowd to tell us whether it's raining where they are now. So in this way, we can take the forecasts from the NEA and we can add to them real-time data. I think I've killed the... Okay, so where was it? So the NEA, let me recap what the NEA give us, is the NEA give us a 3-day forecast, they give us a 12-hour forecast, and they also give us something called a nowcast. And a nowcast is a 3-hour forecast. Okay, the nowcast is really, really useful. Okay, and we use the nowcast to send you alerts. So you can go to the app and you can say, I want to know when it's going to rain in Marine Parade. And we will use the nowcast from NEA to warn you ahead of the rain. But then we ask the users to tell us whether it is actually raining. Because the nowcast is still a 3-hour span. What the NEA are saying to us with the nowcast is we think it's going to rain sometime in the next 3 hours. What the crowdcast allows us to do is know right now where it's raining. Okay? So we get a 3-day forecast, a 12-hour forecast, a 3-hour forecast, and the real-time information on the weather conditions. If you're a weather geek, it's heaven. If you want to know if it's going to rain or not, it kind of works. Okay? Most people aren't into the weather as much as I am. Okay, so this is these icons here actually represent the nowcast. So you can look down this screen, and the NEA is basically saying it's thundery showers in the next 3 hours in all these locations. And here, the users are telling us what's happening. So in the case of Chai Chi, the 3-hour forecast is thundery showers, but the users are actually saying it's not raining at the moment. We've got a grey icon there as opposed to a blue one for city where it is raining. Okay, and with most of our apps we try and find some way to build in push notifications. Okay, we don't expect people to be opening this app to find out the weather most of the time. That's not the way people use mobile devices, right? It's not. Mobiles are, again, a bit different from the web, in that with web I'm used to going and pulling information all the time. On mobile, it's much more, it's a really powerful push environment because we have the device with us 24 hours a day. Our ability to proactively send people the information they need based on their requirements is extremely powerful. We can ask them to tell us where they live or where they're going to be. We can monitor where they are. So if you switch on weather nearby in the app, we're just trying to figure out where you are and tell you if it's going to rain there. So we're trying to make sure that this app uses push mechanisms to keep engaging users, because they won't keep going back and opening this. They'll soon forget about it, but push allows us to keep interacting with them. And something else we've built in, kind of because it was there, we also show another source of real-time data, which is the NEA's radar imagery. Again, no API for this, we have to scrape this. So we scrape their radar images, which are a bunch of JPEGs that are kind of created at frequent intervals, and then we build a small animation to see the radar imagery. Okay, I talked a little bit there about crowdsourcing, because we did crowdsourcing in the weather app. Right, in the weather app, when we did what we call the crowdcast, which is asking the user to tell us whether it's raining, what we're doing there is this thing called crowdsourcing. And there was lots of discussion of crowdsourcing this morning. It was mentioned several times. And crowdsourcing is kind of one of those things, every meeting we go to at the moment, people talk about crowdsourcing. I don't know why, it's just the latest buzz thing. I guess all the CEO conferences, or all the IT conferences you go to are talking about cloud and crowdsourcing. So, people come back from these conferences and they say, oh, we need our app to do crowdsourcing. And then we go, well, why? And they haven't thought of that, right? That's the typical conversation. In fact, typical conversation with us and the client is we walk in the door and they say we want an app. And we say, okay, great, what would you like your app to do? Oh, we don't know. But the CEO's got an iPhone. But it's a lot better than it used to be, because that conversation used to go, oh, we want an app. And we'd say, why do you want an app? And they'd say, oh, because the CEO's got a BlackBerry. Okay, so let's talk about crowdsourcing. Because we've done quite a bit of experiments with crowdsourcing. Some of them have worked, some of them haven't. Also, there are different types of crowdsourcing, some of which are easier to handle than others, or easier to be successful with than others. So I'm sorry, I've crammed them all in here to save some time, and I'm still going over my time. I'll get through them quickly. This is an app that tries to crowdsource the conditions of the MRT. Okay? Those of you who are based here in Singapore, know Singapore well, will know that we occasionally have breakdowns on the MRT. Very, very rare. Hardly ever happens, trust me. Our MRT is the best in the world. But occasionally there's a gremlin, okay? So we wanted an app that would allow us to find out when those incidents occur in real time and warn other users so they could do something about it. So rather than 4,000 people turning up at Harbourfront, not being able to get on a train, maybe a couple of thousand of those could choose to go and get on the buses or do whatever else they want to do, spend more money in Vivo City, rather than trying to use an MRT system that's currently dysfunctional. So that was an attempt to get information from the MRT system. The second one here is a very different way of kind of crowdsourcing. This relies on a crowd. This app will only work if we get loads of users. Because you need people all over Singapore using the MRT, remembering to open the app, pressing the button, telling their fellow commuters what's going on. You have 50 users, you're screwed. You have 500 users, you're screwed. You probably need like 50,000 minimum using this. Otherwise the data you get is just, it's no good. It's not reliable enough. Because with crowdsourcing, there's always the joker, right, who says it's broken down when it's not broken down. And you need the 9 honest people to kind of, tell you the true information. So you have to counter that problem of the crowd isn't always particularly wise. Sometimes the crowd is a fool. In this one, the middle one, this is an app that we built for the NEA, the National Environment Authority, and it's a way for the crowd to tell the NEA about rubbish. It's called CleanLab, and it allows a user, it's basically Insta-crap. You're familiar with the term crap, right? In English jargon, we use crap to just mean rubbish, litter. So if there's rubbish on the ground, we might say, oh, this place is full of crap. We often call this, we don't say this to the client, but we often call this app Insta-crap, because it's Instagram for litter. I open the app, I take a picture of some litter, I send it. Except instead of going to my social network, it goes to the NEA. And it gets posted in the app, so other people can open the app and see if that incident's already been reported. And it creates a case in the app, which users can always go and look at. So they can see when that incident was cleared up, they can comment on it and so on. It's just like Instagram, except it's for reporting litter. Okay? I'm going to come back and talk more about the success or non-success of these in a moment, but it's a very different type of crowdsourcing, because this is useful even if just one person in that vicinity takes the picture of that litter. Yeah, if that's a serious environmental problem, because it may not be litter, right? It could be things like dead animals, it could be serious environmental problems. If just one person uses that to report it and it gets cleared up, everybody's kind of benefited. So it's crowdsourcing, but you don't really need a big crowd. And then this third one is another completely different type of crowdsourcing. This is a traffic app where we basically use the app to feed out traffic incidents. So we get the feed from the LTA that tells us when a traffic incident has occurred, and we plot it on the map. Right? And you can open the app and you can see all the current traffic incidents. So this is from this morning. 12:19, I opened the app. There was an incident. Thank you, Justin.
Sorry, I'm sorry.
And these were the incidents, okay? But that's not really the point of the app. Okay? This app crowdsources data in a very different way. If you go to the settings of this app, you can allow us to collect your driving data. So you go to the settings, you flick a switch, and once you flick that switch, we will start learning what your driving routes are. And typically, drivers have 2 routes they use more than any others. To work, work to home. Every day, right? It's the daily commute. Unless you're a professional driver, unless you're a van driver, or a taxi driver, or something like that, typically most drivers are doing those 2 routes over and over again. And the time in which they do those routes is almost the same every day. There may be a few other routes they use. They may go to their mothers or a family member or go to the kindergarten or whatever. But basically people have maybe 2, 3, 4, 5 regular routes they use. After you flick that switch, we can learn those routes in about 3 days. And from that point on, this app becomes what I call an ambient app. And by that I mean you should never have to open the app again. Because now we can just tell you if there's an incident on your route, when that incident happens, if it's on your route and we think you're going to be taking that route. Okay? So now we've got an app you never have to open. It's an ambient app. Right? It uses the sensors to intelligently figure out your behaviour. It takes this big government pool of data of what's happening with traffic, and it matches the two to try and solve a problem for you. The problem we're trying to solve for you is getting you home on time, or getting you to work on time, We're trying to give you a key piece of information that can help you make a better decision about how you do that journey. And we're trying to do it without forcing you to open the app. We've all got thousands of apps on our phone. We don't go and open them most of the time, right? We open a few key ones. But there are ways in which we can use this device as a sensor to interact with you proactively in very intelligent ways. So let's look at how these have worked, okay? This was a great hit for the first 2 weeks because there'd been loads of breakdowns in the first 2 weeks. We got an article in Straits Times about the app. Loads of people downloaded it. Every night in the office we were having great fun because there were breakdowns during that week. People were reporting breakdowns. Everyone was saying how wonderful the app was. And then they figured out how to stop the breakdowns, right? The MRT system stabilized. There were no incidents for like 6 weeks, 8 weeks. People completely forgot about the app. We got no more publicity. It kind of dried up. We have around about 60,000 users. But when there's an incident like there was an incident about 2 nights ago, I think, on the NEL. We had like 3 people report it. Right? Trying to solve a crowdsourcing problem where you need a huge crowd is really, really tough unless you can get tens, hundreds, maybe millions of users. It's a tough ask because people don't naturally think, oh, I must open that app and say there's a problem. Okay? You just disappear from their mind. You know, that's the big curse of apps. The biggest problem with our apps is not getting people to install them. We're kind of pretty good at that. But you've got to get people to keep using them. Yeah, otherwise it's just part of the graveyard that sits on their phone, right? Most people's phones are a huge graveyard of apps they haven't opened for like ever. Yeah? So, not a great success. Nice idea, got us some publicity, maybe even got us a couple of clients because of the publicity. Right? So it kind of worked for us, but it doesn't work at solving the problem. This has been really successful. The NEA app, CleanLar, it only has about 8,000 users, but it's had more reports than it has users. We've had over 8,000 reports of environmental problems via this app. It's something people really, the feedback we have from both users and from the NEA is this just kind of works. If I walk out my door in the morning and I see loads of overflowing litter, or I see drains that are flooding because they're blocked, or I see a potential dengue mosquito issue, I take a picture, I press a button, it goes to the NEA. I don't have to call them, it goes to the NEA via their email, that email creates a case, that case is recorded so other people can see that that someone submitted it, other people can comment on it, NEA can go and comment on it and say, oh, we came and this issue was already cleared up, or whatever they want to do. So it's not huge numbers of users, but as a crowdsourcing app, we're really pleased with the way users have engaged with this. And it really seems to work, this idea of just getting a person to report one thing that's important to them. And then, of course, the other reason why it works is NEA do actually follow up. And if NEA didn't follow up, the whole thing would fall apart, but they're very good at following up on it. The traffic one, we're kind of not so sure about that. We love the idea, we love we had great fun building the technology, we learned a lot about this whole idea of building an ambient app that learns stuff about you and tells you stuff back. I don't think at the moment we've got enough data from the users to really know whether this is useful to them and helpful. So kind of early days on that one. But the reason I wanted to go through those is because this whole crowdsourcing is not just about one type of crowdsourcing. There are many types of ways to get data back from your users. Either them giving it proactively or them giving it somehow in the background.
So I have a question. How would you improve the Mana Rapid Transit then? How would you improve that?
I think there's a couple of issues. There are some usability issues with it. People found this whole interface confusing. So even in that first week when we got a lot of downloads, we got quite a few people reporting to us saying, I don't know how to use this and I don't know what the information means. So I think we screwed up some stuff there. Maybe if we hadn't screwed that up, the problems would have been solved because that would have kept us more users.
Right.
And the problem with this app is just you've got to have lots of users.
Right.
Because if you don't have lots of users, the problem can't be solved.
But how about the other problem where you mentioned about people forgetting that there is this app that they can actually say there is a crowd problem right now?
What we've tried to do is it has push in it.
Right.
So one of the ways to get around this graveyard problem of your app just becoming part of the graveyard is to use push. It's a fine line because you don't want to be over-intrusive with people, but one of the things that this app also does is it pushes any tweet from SMRT. So if SMRT themselves report a problem, we will push it to the users based on their proximity to that problem.
And do you see an increase in the usage, or do you...
We see an increase in people reporting.
Right. Okay.
Yeah, but it's not crowdsourcing. You know, the original intent of the app was to try and do crowdsourcing, but all we're really doing is we've become a broadcast channel for SMRT. You know, yeah, but if that solves the problem, you know,
but SMRT takes very long to broadcast.
they're much better. They used to take a long time, but because of all they've had so much grief, right?
Yeah.
I mean, the poor guys have just been hammered the last few months. They have improved considerably. I've got 5 minutes more. I've already gone on for 25 minutes too long. And he's giving me 5 minutes more. It's his fault. Don't blame me. Okay. I will be really quick, I will. Okay, challenges. Some of the challenges, I've kind of talked through most of these already. A huge challenge, of course, with any app is you've got to get users. So many apps out there, new apps every day. Getting users is a bit of a nightmare. We tend to rely on our own network to kind of seed users at the beginning. We talk to a lot of journalists. We try and just use our kind of reputation because we're a relatively large kind of app developer to try and get people using the app. But actually getting users keeping users is just as hard. Okay, you can quite often get a lot of users early on because it comes some sort of successful publicity that you've got for your app. So there are always journalists at Straits Times looking to write stories about apps. It's kind of the current lazy journalists mode. If there's no news in Singapore, I'll write about another app. Right? So you can get people to write about your apps in Singapore, and Singapore is a relatively small, incestuous place where you can kind of get word spread, you know, relatively easily, much easier than a lot of other places. So that can kind of get you the first kind of test bed of users. But then you've got to obviously grow from there, and you've got to try and keep those users using it. I've talked a bit about using push and other mechanisms to do that. Third challenge, of course, is maintaining these types of apps. Things break constantly. If you're reliant on third-party APIs to pull this data in, something at their end can break, something in your middleware can break. The end result is the user goes to get their trip, they open NextRide, they go to get a trip, and they get the spinning wheel, right? Because some API is broken. Next thing you know, 1-star review in the App Store. Guaranteed, right? They'll never use the app again. All they'll do is they'll take 5 minutes to go to the App Store and give you 1 star. Okay, and you've suddenly started down this kind of slope of dismay. So you've got to maintain things. If you're providing people with a real-time service to solve their problem, it's got to be real-time. And as soon as it isn't, I'm afraid users are bastards. I mean, they're just completely unforgiving. And you know what? You give them stuff for free, they're still bastards. It's not like they pay for any of this stuff, right? Okay, then you've got the nicer problems. Okay, scaling. We love scaling. That's a fantastic problem because we've got users. Scaling, now you've got a really interesting problem. Yeah, you're only scaling because you've got users. Don't pre-scale. Don't bother about scaling early on. Okay, that's like premature ejaculation. Don't bother. You want to scale, you know, when you're ready to scale. Yeah, and most, some people say, well, you might have made the wrong technology choices. Most of the stack that is used these days is kind of scalable. If you made a really bad decision in your technology stack, you can probably rip it out if you need to in a few hours or days. None of these things are that tough to work with that you can't swap around as you need to scale, but don't do it before you need to. I guarantee most of you will never have to, because that's the nature of the beast, right? There's only a few apps out there that really need to scale. But scaling is a wonderful problem, and it's so easy to do now because of the cloud. Right? We use Amazon's web services for all our back end. We can fire up servers in 3 minutes and have them up and running, serving more users. We can scale them down again so we're not paying extra for them. It's a fantastic flexible server for kind of startup guys like that. Flexible service for startup guys like us. And then finally, I guess, monetizing. I'm not sure that's particularly appropriate to this event, but you never know. One of your, some of your ideas may be something that could become a commercial offering at some point. How are you going to monetize? In our case, we've chosen not to charge for any of these apps. SG Next Bus does run adverts because it has 150,000 sessions a day. And with 150,000 sessions a day, you can get a few $1,000s in advertising. But it wouldn't be enough to live off. Right? Even with that level of usage, it's just nice to have. The other apps we keep free, they're not advertising supported. Why do we do them? We do them because, as I mentioned earlier, they're our sandbox, they're the way we train guys, they're the way we have some fun, because a lot of our client projects are so damn boring. So they offer us a lot of things, but also they're our portfolio. I mean, just like any graphic designer out there, you see these graphic designers going for job interviews and they have this big case of their work, right, in a folder. This is our portfolio. This is how we get our client work. We would much rather spend our time building a neat app than doing a PR exercise or whatever else you want to do as marketing. So our marketing is to sit down and have fun being geeks, get some users, get some publicity, hopefully get more client contracts. And I think that's it, believe it or not. That is my last slide. I just wanted to finish off. I talked about opportunities earlier. I just want to reiterate what I said earlier about the opportunities. If there's one thing you can remember from this presentation, it's the container ship and the speedboat. Okay, if you're building a mobile app, think of it as a speedboat. Fast for the user, fast for them to solve their problem, fast for them to get the data they need to solve their problem. Can they do it in 20 seconds? All those sorts of things are what makes an app successful. So try and remember that image. Thanks. Sorry if I went around.
So we do it this way. There was supposed to be a speaker panel at the end of the session. Maybe we can just scrap that, and instead of that, why don't we just ask any questions for John? You have any questions for John? Okay. Yeah. Any questions? Okay, there's one question. Yeah.
With new opportunities such as like Windows 8 and Windows 8, do you think your company had feel that there's a need for you to develop apps for such platforms, or you're going to take away anything?
Definitely wait and see. I don't think Windows 8 or BlackBerry, I don't think we know enough about them yet to start even heading in that direction. We'll kind of keep on top of them, by reading about them, but we're not going to build skills in those areas until we see whether they can gain any traction. At the moment, our approach is basically, most of our apps are Singapore-based, so our approach is still to build iOS first, but always do Android as well. So for the first few years, we quite a few of our apps, we just did iOS, because iOS kind of took over Singapore, but now Android is kind of, caught up, so we now do both, but we always do iOS first.
Any other question?
Yeah.
You mentioned about monetizing applications. You said that adverts only work for those with very high volume. So are you saying that it's impossible to monetize from apps in Singapore?
I wouldn't say impossible, but I think it's pretty damn hard. If you're going to run, that particular app is could maybe just about keep one person in their living. It's making a few $1,000s a month in advertising, and that's with over 1 million downloads and roughly 150 sessions a day. So if you can build an app with that level of usage, yes, you could monetize, but you're not going to become a millionaire. And there aren't many opportunities to build apps with that level of usage. I think in Singapore, the huge usage amongst apps is still non-Singapore apps, right? It'll be Facebook, Twitter, and then after those, you've probably got the Straits Times, which we know has huge usage because we built that app. That's well over 1 million downloads, and things like SG buses. Outside of that, it's very difficult to get advertising revenue. There have been attempts by Singapore companies to monetize in other ways. So a good example is GoThere.sg. Have if you look at the Go There app, they came out with a really great transport app. And they charged for it. I think it's like $4.99 or something like that. And I think they kind of did okay. Other monetization opportunities, I can't think of many good examples in Singapore, I'm afraid. In Singapore, a lot of these apps are built because people want to learn and have some fun and contribute. And if you want to make money, you've probably got to have something that's going to scale outside.
All right. Okay, let's thank the speaker one more time.